Awesome. Thank you so much, and welcome back. So we are talking about the next topic here, which is which is about Manila and deployment at the edge. So there is an Etherpad that I started collecting notes, and it is sort of an ad hoc topic, kind of lured John into this. But much of these notes are from notes that he's written or shared with the O community or with the downstream Red Hat documentation. So I guess what I intended to do through this session is to like call out exactly what folks are trying to do with the edge deployments, and I mean, what are the specific use cases to have file shares at the edge deployments, and how should Manila evolve to be deployable at the edge? As in, what are the current problems? Why is it not deployable at the edge? Um, and just kind of drive that discussion. It is going to be related to the discussion that we are going to have tomorrow about changes to the Manila share service. But this is a perfect use case for why we want to do stuff like that. So this Etherpad is linked out of the main PTG minutes Etherpad. Let me know if you can't find it. And how do we want to go about this, John? I don't mind introducing and then asking you questions, if that's a good.
That'll be fine with me. I'll do my best.
Awesome, thank you. All right, so at the get-go, for folks at this that have been focused on Manila for a while, here's what the edge deployments and the edge architecture looks like, and this is what Red Hat's doing, right? So an edge architecture is basically a geographically distributed infrastructure, and it could be many things. And there is an edge computing group that's been working for quite a few years now, defining different kinds of architectures that can happen with edge. And this particular session, I'd like to focus on one of those, which is the aspect of distributed compute node, where the control plane for the cloud is centralized, and all of the command and control for the entire cloud happens from the central site. So users are interacting with the central site, but they are able to deploy their workloads at an edge site. And what is this edge site? Well, it could be one or more compute nodes, and I mean, that's how it kind of began with, and now with architectures like O, you're able to deploy one or more compute nodes with storage. And the storage can be one or more, dedicated storage nodes, or it could end up being a HCI deployment where compute and storage happen to be on the same nodes. And how do we think of these edges? One aspect, yes, is the geographic distribution, as in there is a central site with the controllers and maybe some computes. You can certainly have an entire OpenStack deployment on your central site, and you can have an edge site with just compute nodes. There are no controllers at the edge site, and the other aspect of this is that each of these edge sites is a failure domain in itself. So in case of your workload that's running on a particular edge, should there be some sort of an issue with that particular site, and there's a site failure, it should not affect workloads that are running elsewhere in your cloud, at different edges or maybe at the central site. So that's sort of the design. And it kind of dovetails very well with the way availability zones are thought about in OpenStack. I say that with the risk of people pointing up and saying, "What? No." But that's kind of at least how we think of AZs so far in the shared file system service. So some more notes out here, especially around why this central architecture and the central orchestration layer matters. Well, a few things that it solves would be stuff about being able to manage all of your remote infrastructure from this central site, having your users command and control via the central site and perform their deployments kind of eases the aspect of the user having to know where too much about that edge site. All they need to know is perhaps that they want their workload running somewhere, but not much more about, hey, do I need to authenticate to this edge site separately? Do I need to talk to this other different endpoint to create a resource at this edge site and stuff? So you let the services that are running in the controllers decide and help with all of that. All the user needs to do is be able to say, hey, I want my workload or whatever provisioning that is needed for that workload happen at this edge site with the help of maybe something as simple as an AZ, right? So you can say Manila share create hyphen AZ edge site X, and that's gonna make sure your resource is created at that edge site. The other aspect is being able to view all of your stuff using a single pane of glass. There isn't I mean, just like how you would do your provisioning and your lifecycle management, you'd also probably be running Horizon or even using the CLI commands to take a look at what your infrastructure field looks like, and that interacting with a central site as opposed to interacting with X number of edges is easier. And there are some more things around updating and upgrading remotely and the kind of resiliency that is offered. So it's for specific use cases where this sort of edge makes sense. And I guess that would probably be a good question to John as to what are people using this sort of deployment for?
Sure. It's to solve latency problems at the heart of it. One way to deal with, you can't do anything about the size of the earth, so you move the workload to the user. So it's just a matter of the data has, sorry, the distance from the user to the data center can be reduced if you can move part of your data center closer to the user. And when you do this, so instead of having a couple of large data centers, you could have a lot of small ones this way. So people end up putting these things at the base of cell phone towers, or then I need to run a workload out there. I don't have a lot of space, but I want to put some compute nodes out there and I want them to run a workload, and space is constrained. So I don't want to have 3 nodes out there just to have a controller. Like, I just want a couple of computes, maybe even just one. And then we can do 3 with HCI, so that we can at least have Ceph co-located on those compute nodes at the edge site. So that's what I think creates the demand for this feature. And for those users, they can use Ceph with Block, but they can't use it with Manila. So I think that's like the next problem to solve, so that those workloads can have Manila shares.
Awesome. Yeah, and why NFS shares at the edge? Well, one of the biggest drivers, I think, that got us motivated to talk about this is because people want to be able to run OpenShift or Kubernetes at these edge sites, and we've seen this as a logical progression of things. So what are they running their applications on is what's kind of driving the decisions that we're making with the infrastructure as well. So VM workloads with block storage are probably the first step. People probably want to run VM workloads with shared file system storage, but there is an increasing number of people that or users that are interested in running shared file system services with for the sake of consuming them via container orchestration systems and substrates like Kubernetes. So that's a major driving factor. And I mean, Tom's done a lot of work in that space, so feel free to jump in, Tom, if I'm missing something.
Even though with workloads and VMs, writing to a common share from multiple nodes is very legitimate, and there are a lot of use cases for that. With Kubernetes, it can end up being something that users do without even trying, basically. They deploy multiple applications or multiple instances of applications on multiple nodes without, that's what you're going to do unless you work hard not to do that. They're just going to be spread out over the multiple nodes. So if they're doing multiple writes, multiple writers, they're going to need a shared file system. If they're using file system access mode, which is what most applications do. So I'm just underscoring Betham's claim that OpenShift workloads and Kubernetes workloads particularly drive the need for this, and there's interest in running those on stack at the edge.
Awesome. All right. The how is probably the next part of that question. So there's extensive documentation about how O does this today, and what the Cinder side of things, which is this distributed backend storage, is probably more interesting to us. Of course, the Metadoc on how the compute nodes themselves are configured, and especially the notes about networking is going to be important and interesting as well. So with distributed multi-backend storage, the idea is to take advantage of some things that the services natively support. And in this aspect, Cinder and Manila are very similar. They're able to configure multiple backends in a given deployment. So if you have at a central site an existing Manila service, adding a new service at an edge site could just start with the Manila share service that reports to the central Manila service and registers with this service and allows provisioning at this edge site. That's the basic concept. And we know that I mean, we also support the the delineation of availability zones with these backends. I mean, our services are tied to availability zones, and we've provided overrides at the backend level, so you can do multi-backend at a given site with different AZs, or you can do multi-backend at different sites, each with a dedicated AZ. So there's this flexibility that both Cinder and Manila have. That's what's taken advantage of with respect to Cinder. And currently in the DCN architecture, Cinder is being run active-passive at the central site and active-active at the edge sites. And that's the bigger piece of this puzzle, because the reason it's being run active-active, I guess, let's probably ask that as a question, so I can get to hear it from Chania. So why do we care about an active service versus an active passive service at these edge sites?
Well, sure. I mean, on the in the case of Manila, we basically did not. I'm sorry. In the Cinder example, we did active because we did not want to run pacemaker. We didn't want to run pacemaker at the DCN sites because we did not want to be fencing HCI nodes. So I mean, basically, if I have a 3-node Ceph cluster, then if I fence one of those nodes, I'll lose a third of my OSDs, right? The more nodes I have, the better I can survive losing a node. But in an edge deployment, you're space constrained, so you might only want 3 nodes. So Pacemaker just doesn't mix well in this type of environment. Because again, these aren't controller nodes. These are, compute nodes, workload type nodes. So luckily Cinder had been working on active-active, and they pretty much had it ready to go. So that's what we did. So I assume we would, if we wanted to follow the same pattern in Manila, therefore you would want to have active-active. But I don't know the state of Manila active-active. But here I am with all the Manila developers. So.
Absolutely, and it's been a theme of thought and development in this community for a while. Except, by default, we've not made a lot of recommendations. And tomorrow's talk is going to cover that a little bit more. So we want to eliminate all the pitfalls that come with running the Manila Share Service active-active. And the reason we don't support it in TripleO is because it's not being tested upstream as a supported thing. Hasn't prevented a lot of people from running the Manila Share Service active-active and discovering issues and fixing those issues. And there are a number of these, and we've kind of touched upon this over a period of time. You'll see more of this in tomorrow's talk. Yep. So these are the two things. These are the 2 or 3 things that are crucial in the configuration of Cinder that allow it to be deployable at the edge. So I mean, just rehashing the picture a bit. So you're going to have a central site with the Manila API, the Manila scheduler, the Manila share service, perhaps if you have the need for it at the central site. And you will have at each edge site just the Manila share services. So the central site and the edge sites are going to communicate over RPC when they get a provisioning or a management request that they need to hand off to that particular Manila share service. And there could be issues with reconciling this RPC. So an edge site can go unresponsive because there could be a network disconnect between the central site and the edge site. So that kind of was going to be my next question. How is that handled today? Are failures expected, or is there some sort of remediation for that kind of failure?
Sorry, Gotham. I wasn't.
Oh yeah. Okay, I can repeat.
Yeah, I apologize.
Nope, no problem. I was just trying to ask my digital assistant to stop giving me the news, so I muted. So the question was, given this architecture where we're trying to send RPC requests over the wire to an edge site, and with the possibility that there could be a network disconnect between the edge and the central sites, how does that work today with Cinder? When there's a network disconnection, is that supposed to be picked up back when the network has come back? Is there some sort of a retry logic that's going on?
I would prefer a Cinder developer answer that.
Right.
I mean, basically in the testing we did, and including Nova, I mean, the assumption was that you will get disconnected from your control plane, and that the service should be able to recover when that happens. And testing was done on that. But someone who works on either of those projects could better answer the details of how they had RPC handle this. And I suppose that's an additional challenge if you're going to do this for Manila. You're right. That's the question to ask, but I couldn't really comment on how. Sorry.
Makes sense. Tom, I think you're trying to talk and muted.
Thank you. Do check with Cinder, or we should check with Cinder, but my impression is that there was not a requirement that the control plane retry requests after a long period of disconnection. There's the normal, it's going to try 3 times or something like that, the type of failure in provisioning stuff. But I don't think it replays and retries. I think it just shows up as an error in the case that the edge, you want to provision something and the edge site is not reachable for a long time. But we can check. But I don't think that's a requirement for our edge deployments today.
Yeah.
And that's distinct from data plane connectivity when that's supplied at the edge, right? So if you have a Ceph cluster supply, as an example, supplying storage at an edge and consumer at that same edge, it will continue to work when the edge is connected. But you may not be able to create new volumes during this.
Exactly. So the workload keeps running. The control plane may not work. But if the workload you deployed is active, that's that's the important thing. I mean, in this architecture, that's the trade-off you make.
Absolutely. And this kind of probably imposes the requirement that, I mean, now that we're talking about NFS Ganesha moving closer to Ceph, it maybe alleviates that issue. But today, if we were to do that, that's another concern that we have, which is that NFS Ganesha runs by default on the controller nodes. You could make it run on a different node if you wanted, but we would have to go through a bunch of hoops, and we'd have to make sure that the NFS Ganesha service is being deployed at the edge that matters to the workload.
I mean, I would think this would tie in with the previous session, right? That you would use the PCS list method we were talking about.
Yep.
Very much so. I mean, I think that although it would be possible to solve it without migrating new stuff, why bother, right? I mean, we get that with the Ceph managed, because each cluster can have its own Ganesha cluster.
Yep.
Each edge site would have its own particular one.
Each site.
Yes, each site.
Each site. And then the other data plane, the other backend service stuff that will work well for this is BirdIOFS. So we can just log that too, which is a parallel effort we'll be talking about. And vendors are very much invited to think creatively and talk with people about how to work in a DCN edge environment. I'm just talking about the backends that are under our control.
Right. In that aspect, I don't anticipate a lot. I mean, vendor storage that is not deployable. I mean, not completely deployable by OOO is probably going to be orchestrated at the edge itself, and it's going to be local to the edge. It shouldn't be running in the central site and connecting to the Manila share service that is at the edge.
Right. Yeah, I guess when we started this, people wanted to stretch Ceph clusters, which you're trying to solve a latency problem. So, moving one part of your interface but not the rest of it, it doesn't make sense for solving that latency problem. You want to be able to write your data efficiently.
Awesome.
I think, there was one thing I wanted to bring up. We discussed a little with Tom, but not sure how many have been looking to that conversation. So when you say active, are we? I think there is a model which can work a bit like the CFMDS configuration, where you don't really have multiple daemons that are sharing load, but you have only one, which is elected somehow to be the only one overreading, but the other two are just ready and standing by to get over the work if the master node fails. So where active isn't really about having more than one daemon participating into managing the load, but it's only about having a quick way to fail over on another daemon without relying on external tooling for it, without relying on pacemaker. I don't know how much this is useful and if it is at all, but in the idea of getting the service to run at the edge, we don't necessarily need to also share load, if it makes sense.
Yeah, totally.
I do think that makes sense. I tried to that in the line I put. That's what I was thinking about. We have been thinking in terms of active, partly because our architecture is rather like Senders, and we may be able to leverage some of the work they've done, but I think we should keep an open mind when we do that. We leader election for things like periodic tasks. One node. So we can think about, would it make sense to generalize that leader election type approach and just do everything with one node and don't load share, if that makes life easier.
There was a comment in the pod about it. Sorry, I missed it. I am only seeing it now.
No, I'm glad you brought up the point because you explained it better than my comment.
Sorry, I didn't see it, Tom.
No, you're right. I think we did discuss that a bit about the leader election part. So far, the service architecture that we have, the way we've I mean, we could do some of this with the Oslo service. We just need the corresponding service to be running as well. But it being on active standby is kind of what that active piece really is, and that's kind of what I was thinking of as well. Like I mean, it doesn't have to be as complicated as such. And I was going to reflect on this in tomorrow's talk and just talk about DCN here. But I'll add that our approach to active is not all that radical as I mean, it's probably what you're saying, Julio. It isn't. It is about it's like an MDS. It's not going to be load sharing. It can be, but we're building it more about recovering from failures and being resilient to disconnection sorts. And somebody was and always having these recovery loops also come through the same service plane that we currently have right now. We don't do that. We just we assume we are the only ones running, so we do a bunch of recovery, and we do this at regular intervals and stuff like that. So and the way we'll change that should allow for that, which is going to pretend like an active and an active standby. So and yep, I'll share some more details in tomorrow's talk for that. So we are, I think, at the end of this discussion portion that I was looking at. The other futures we've already started discussing, and dealing with some of this in the feature land, and as far as Manila is concerned, especially when people at edge sites want to replicate their data between edges and stuff, and we have mechanisms to do that. And I see that CFFS is something that is looking to that is supporting mirroring data from a file system on one cluster to a file system on another cluster and stuff. So we might think about building on top of that based on this architecture as part of our futures. So if there are other ideas like that, please do call it out so we can effectively keep them in our roadmap and our heads as we're working through this. And in terms of work items and action items, we were not supporting the AZ configuration at all, if I recall, Carlos. And right now you've made that possible, and so that's a good piece. And a similar thing will be required by all other tooling that wants to do this. And tomorrow we'll be talking about the active part, what are the changes that are coming in the yoga cycle, and the other part of this is that shared drivers must parallelly start testing the active as we're working through this. So we might create some documentation, and if you're a driver author, driver maintainer, please collaborate, because we might not know the specifics of each storage system. We certainly don't. It's not a question of might. So there's going to be many questions that will come up. So we'll keep revisiting this as we make those changes. So part of that is making sure we have a strong testing or qualification criteria. So things, when deployed like this, are not running into some problems. And some other things with respect to pitfalls, and we should probably write this down in the general design guidelines that we have for the contributor doc, that we are these are distributed services that should not be depending on each other, and should be built for failure. And part of that would be thinking about coordinating between services, an example of which we've kind of spoken about in the past. And yeah, we just touched about the NFS Ganesha piece, and we're working on fixing that. Any other concerns, topics for this?
I saw that under futures, there was the idea of share replication and data copy across edge site, and I thought I just wanted to let you know what's going on with just briefly how it works with Glance and Cinder today, because the Glance architecture is a bit different, where we're able to, Glance has multi-store support and multi-backend support. So you're running one central Glance, and you can create an image, and then you can make a copy of that image at a secondary Glance store, which there's a separate Glance store deployed at every edge site, though it has its own local Ceph storage. So that's how data is moved for Glance, and it retains the same image ID between different edge sites. So it has this concept of, here's an image and these are the backends it's available on, and now make it available on this new backend over there. So for Cinder, we can create a volume at any availability zone, but we're also able to run the Cinder backup utility to back up this volume at another site that's remote to it. I mean, but what's going on is you're doing RBD over the wire, over the WAN. So it's slow, but it gets there eventually, and it doesn't need to be fast. It's a backup. So for the share replication bit, I'm not sure. I mean, for Cinder backup, it made sense for that. The idea that you can move the stuff, but that the movement will be slow. and I wasn't sure how share replication might work. I just saw the topic of copying data across edge sites came up and wanted to just share those parts. There has to be some data copy across edge sites, but it's understood and accepted that that's going to be a slow thing.
Absolutely. And I can touch upon it briefly, and we can follow up. I can send you some material or link it right here. So Manila's replication is driven by tenants in the sense an administrator is configuring the things where replication is possible when they're setting up their sites, right? So if you could think of it theoretically as somebody that's deploying an edge site knows beforehand, where all the replications are going to be possible, or can update these sites and create these replication rings, where data can be moved and copied. And tenants have the ability to go then create these replicas. As per demand, so on demand, so they can create a share, and then at some point in time they say, okay, I need to replicate my workload in this other availability zone, and they can add a replica, and then this other availability zone, and so on. So they're they can do this sort of fan out replication. There is no concept of backing up stuff, but
Right.
there is point in time snapshotting, which is very similar to Cinders, and if you have replication, these snapshots are transferred as well to your replicated sites. So that part is again, controlled at the tenant level. Yeah.
When we the way DCN works is a hub and spoke model, where the hub is the central site, and that's where the control plane lies, and then each DCN site is a spoke. So the spokes can't talk to each other. Everything has to go back through the hub for like the Cinder backup I described, right? I can't back up from DCN site A to DCN site B. I back up to central, but then from central I can push anything wherever I need to. And the Glance multi-store is similar. I can't move images between edge sites unless I put them at central first.
Oh, I see. Okay.
So those storage networks are
Isolated.
they're shared, right? But I'm trying to figure out how that share replication might work, given that that's how DCN is set up by default, and if having the hub makes sense for that. And I guess it's a future topic.
Yeah. No, you got something for me to go research. Thanks for sharing that. Yeah, the concept over here is that the administrator has set up the networking such that this replication is possible. But if they need to consider then that there should be an edge-to-edge connectivity for the storage network, because that's all of this replication logic is handled at the shared driver on the storage. So if you're talking even CephFS replication that will come someday, it's going to be initiated by the Ceph cluster that's transferring the data to this other Ceph cluster. And so it's not going to go through the Manila service plane at all. The service plane is just orchestrating this, saying start this replication, and then
yeah, sure. I understand. I mean, in our case, I did describe the control plane as being central, but in addition to that, there's also a central service. Like there's we have Cinder volume running central, we have Glance running central, and these are just analogies. I'm not saying you have to do it that way. I'm just explaining how it is. So I don't know if we can get more into it another time, because I think we're just trying to get an MVP here, not solve a future problem.
Yeah, that's true.
But is the idea that we were to use Manila replication in this context that we'd want to constrain it to the hub and spoke topology? Is that what's being suggested?
I'm wondering if it were constrained to the hub and spoke topology, it would at least fit the existing topology.
Yeah.
But if we need to change the topology, then it can be changed. But just wanted to point out that that's what we have today.
Yeah, fine.
Yeah.
Awesome. Thanks for that call out. Guess we need to go read some stuff.
Or yeah, I have to learn. I think I have to learn a lot about Manila if I can be of more help. So, thanks.
Awesome. Any other discussion around this topic? How are we doing on time? I think we're close. I think we'll finish today on time and we don't have to extend. All right, so if there's nothing else, I think it's time for another short break. Let's take, probably not 10 minutes, maybe 7 minutes. It's a shorter break, sorry about that, but we'll get back and talk about the metadata work that Ashley's been up to. So let me start a 7-minute timer and let's get back. Ashley. Oh,
hey, yes, I'm here.
Yes. Awesome. So I'm not sure if you want to share your screen or you want me to continue.
Yeah, I mean, you can just open up the Etherpad that's linked out of this one.
Awesome. Yep. All right.
All right, great. Hello, everyone. So I wanted to bring up for discussion the metadata spec that was initially proposed by Gotham in the Wallaby cycle, I believe. And so I've been working on it and I've updated some of the details about it. Part of that is in the spec that's linked there. And so, yeah, I guess I'll just kind of give you guys a progress report on what I've been up to regarding that. So the major changes, I guess, would be I've added a few more resources that would be affected by this API change. Most notably, the share instances versus share replicas. They're going to use the same database. So because one API is exposed to the end users and one isn't, so that's kind of like a gotcha in there. There's also 3 databases that already exist. One is the instances export location, one is the share access rules, and one is the share metadata. These databases won't really be changed except for the addition of a deleted field to keep track of these metadata items, but all the other resources, they need their own metadata tables. So that's a pretty large migration that I'm doing in this change. Scroll down a bit, Gotham, please. All right, so the bulk of the work. So primarily the first patch, I suppose, that has to go through is the admins only keys logic that is being used for the scheduler filter hints. The way that I've worked that is there is a ignore keys dictionary in the common dictionaries file. In there is the actual hint keys, but the logic itself, it's part of the API or the database API layer, and I'll be adding that same ignore keys parameter to the other resources as well, so that if an administrator does want to have their own set of keys that their members or users can't change, they can do that. I'm also adding so policies for every resource. The only one that I've kind of hit a bump in the road is the share access rules, because for some reason it's the only resource with pre-existing metadata that it uses a different name for the base policy name. So I'll have to play around with some of the logic on that. I've also added parent-child validation specifically for the export locations API, and the share network subnets API or resources. So there's that. And then all in all, there are 6 proposed methods: the index, create, update, show, and delete. I want to say that's 6 new methods. Yeah. And the way that you can access these APIs is for each resource, there'll just be a / metadata or / metadata / key, depending on what you want to do. In addition to the API changes, clearly, there also has to be some CLI changes and some additional Tempest tests. Some of this work, at least in the CLI, has been started already. Gotham started that. He also realized that we don't want to do the same work multiple times. So we're thinking, at least, to implement these commands only in the OpenStack CLI instead of also implementing it in the shell. And there's going to be more talks about that on Friday, about achieving parity and the Python Manila client shell deprecation. How this would work, we'd be using the properties flag that already exists for share, and then just implementing this with all the other resources as well. And that is one example right there of how to use the properties flag. Let's see, so Tempest tests, haven't started that yet, but it's also not the very first priority right now. So timeline wise, I'd like to have the admins only metadata keys logic merged first, then the API and the CLI, and then the Tempest tests. Hopefully I can get this all in yoga, but yeah, it's a work in progress. So this is the bulk of all the changes, and I would really like it if you guys have any ideas or questions, just something to discuss if you guys want, that'd be great.
This is pretty awesome. I mean, it's a huge change code-wise, because a whole bunch of resources are going to have these new semantics, whole new APIs and stuff. But as far as the user experience, I think it's pretty awesome that we're able to, preserve that piece of this thing, that it's going to be the same consistent experience across all of these resources. Are there any hiccups so far?
Not particularly, at least not that I've seen so far, because I am still missing some unit tests. But I guess most notably would be share access rules and share metadata. There were a few methods that I had to override in their file so that the micro versions previous to this one still work. And then the micro versions, or this micro version, would either include more, well, yeah, it does include more methods, but it also just works cleanly across the board with all the resources.
Yeah, it makes sense. And it kind of makes it easier for us to think of, all of these methods newly, although in the CLI, I think the other call out is that not all of them are implemented, and we don't need to, right?
Right.
So you could create a resource with some metadata. You can update the metadata on a resource, and you can delete the metadata off the resource. But that's pretty much it, I think, from the CLI user's perspective. And this would apply even to the UI. So when we're designing it, we're not going to hit all of these APIs, although they're there. I mean, just for us to complete the semantics around the API.
Mm-hmm.
Great, and the timeline definitely makes sense. Thanks for including that. I like the call out on the fact that we're not doing the, the metadata, keys, the admin only metadata keys as part of the database. I think that's kind of what you're, going to include in the data model impact over here.
Mm-hmm.
So that is a huge change, and I think I mean we kind of tried this approach and it didn't really work well, right?
Yeah, there was a big issue with getting the database, or at least this entry in the database, to actually update and then to use the value as part of the logic. It was a headache and a half.
Right.
So in the end, the ignore keys dictionary just seemed an easier way to implement that logic, and also it still gives the administrator, like enough room to work around with it.
Yep. Awesome. Thank you. And so let's, I guess, what are our action items over here? I mean, you have a lot of action items, which is completing this work.
Yeah.
Is there anything else that you wanted to?
I suppose if I can get some reviews on the admin only metadata. I did see that you put some comments, and I am working on additional test coverage, which is the last part of your comments that I'm addressing. And then once I have those tests up and running on my dev stack that actually works, I will push those changes, and it'll be, I guess the floor will be open for anyone else to comment as well. Thinking of anything else major that I haven't done or I haven't started. The policies, I have to double check the share access rules and figure out a way to get that working because of the name difference. Oh, actually, I do have one question now that I think about it. So the default role for these methods are usually member or reader. But if I'm including the admins only metadata, should there be a default for that?
So yeah, that's going to be a tough one to answer, in the sense the whole concept of these admin only metadata is to accommodate two parts of that. One is something that the service is able to set, like for example this export locations. I mean, we just had a discussion around, you need to be able to say which exports to you be able to use as an end user, and this admin seeded or service seeded metadata helps with that. And you don't want the users to be able to delete those metadata items or manipulate them in any way.
Right.
So that makes it, I mean, because these exports are, I don't know, I think defaulting to the system admin role is not a big deal. But we have to probably ask, is somebody interested in modifying this with the project scope and not the system scope? And maybe it's open for discussion, I think. But I like the approach that we will be calling these admin only and separating that policy out, so that if somebody says, okay, I don't care, my users are all all trusted, they can go ahead and override that policy with what they want at their site. And whatever default we pick is only because, I mean, we want to make a sensible choice, but I mean, this allows the override is the underlying point.
Okay.
So far, I think in the grand scheme of things, it's a minor point, but it enhances the UX around this, even if it is a minor consideration. I did have a bunch of questions, but I think I already, posed them to you with and you've made those changes in the spec. So I'll go back and see what those changes are.
Yeah.
Let's open the floor up. Any other comments, concerns? Words of encouragement for Ashley. This needs to be done yesterday.
Yeah,
Yes, it's good.
that's my advice.
I didn't catch that, Tom.
I was just saying, can you hear me?
Yeah, we can hear you.
It's okay as long as Ashley can hear me. I was don't let Gotham.
Yes. I think it's my end.
That's all. No, it's very nice, Ashley.
Thanks, Tom.
Yeah, very nice. And also, I'd like to single out that I like the decision to implement only in the Openstack client, because, I mean, in this way, we are going to start encouraging people to start only using the Openstack client. And yeah, we are going to have like new features there, and it's going to be like better for people to start using that. And we are pretty close to feature parity on the Openstack client and the Manila client. So I think it's a good time to do this. And yeah, that's great.
Awesome. Thanks.
Agreed. More of that when we talk to Mari on Friday. There's a few things that forced our hand around that, but we are to blame. All right. Anything else? I'm just looking back at the schedule. We are done with all of our topics for today, which is good. So if there's nothing else for Ashley, thank you so much for bringing this up, Ashley. And should you need any reviews or anything, let's talk about this at the weekly meetings, and keep the progress on this.
Thanks.
Yep, welcome. Let's step back. All right, so we've taken AIs in the specific Etherpads if we've made any, or they're sprinkled around here, but you'll see them in my summary when this ends. So just giving you a preview of tomorrow, we will be starting with a discussion on the UI before jumping in with the NOAA folks to talk about Vertio FS. And I guess, Tom, you'll be leading that topic.
Yes, and they have not had their best session yet, so it may be relatively brief.
Okay, awesome. We're still interested to know what's happening outside and towards this topic. And after that, we'll be chatting with Naheem and Philippe about extending the subnet interface within the same AZ. And we'll be stepping into the clustered Manila share manager service for active Manila, and FIPS compliance, SR back, and wrapping it up with some tech debt. I promise not something that we want to that we've built in the last cycle. This is stuff that I'm rehashing from a couple of cycles ago. Anyway, so that's a lot of that's a packed schedule for tomorrow. So very excited to step into that with you. And thank you all for joining today. Let's give ourselves the final 10 minutes back to our schedules, and see you all here tomorrow.
Thanks, Gautam.
Thank you.
Yep.
Thanks, Gautam. Thanks,
you.
everyone. See you. Bye.
Bye.
Bye.